pressure light. Let's start with this topic. On completion of this exercise, the trainee shall be able to determine why the oil pressure warning light is not glowing. Solve the oil pressure warning light's flaws.
Tools and equipments required: trainee's toolkit, multimeter, wire cutter, battery, vehicle in running condition, insulation tape, bulb, sensor, wire as required, cotton waste as required, soap oil as required. Let us start this topic with oil pressure warning lights. Let's get started. When you see the low oil pressure light on your dashboard, shaped like a genie lamp or an old-fashioned oil can, some dashboards might show the word oil. It means there is a big problem with your engine's oil pressure. This is serious because if the oil pressure is too low, the engine won't get enough lubrication, and that can seriously harm or even completely stop your car's engine. Ignoring this warning might lead to expensive repairs or, in the worst case, needing to buy a new engine. Pay attention to this warning. Next, let's discuss the procedure for troubleshooting the oil pressure lights. Locate the oil pressure switch, which is a sensor that monitors oil pressure in the engine. Inspect the wires connected to the oil pressure switch to ensure they are securely attached. Look for any signs of damage or wear on the wires that could affect the switch's functionality. Identify the oil pressure warning light on the dashboard of the vehicle. Inspect the bulb associated with the oil pressure warning light. Verify that the bulb is not burnt out or damaged, as a faulty bulb could give a false indication of low oil pressure. Verify that engine oil meets the manufacturer's recommended viscosity specifications. Check the engine oil level using the dipstick. Ensure it is within the recommended range. Inadequate oil level or incorrect viscosity can lead to low oil pressure. Locate the oil pressure sensor and inspect the connections to the oil pressure sensor to ensure they are secure and free from damage. If it is damaged, fix it. Examine the wiring connection to the oil pressure sensor for any signs of a short circuit. Short circuits can disrupt the proper functioning of the oil pressure sensor and lead to inaccurate readings. Examine the oil pump, which is responsible for circulating oil through the engine. Ensure the oil pump is functioning correctly and not experiencing any issues. Check the oil filter for clogs or contaminants that could impede oil flow. The next troubleshooting that we are about to discuss is the oil pressure warning light does not light up when the ignition switch is on and the engine is off. Inspect the entire lubrication system, including oil passages, pump, and other components. Look for signs of blockages, leaks, or other malfunctions. Ensure that oil is circulating properly throughout the engine. Check the engine oil level using the dipstick. If the oil level is low, add the appropriate amount of oil to bring it within the recommended range. If the oil pressure gauge is providing inaccurate readings or not working at all, replace it with a new functional gauge. Inspect the oil pump pressure relief valve for proper operation. Replace or repair the valve if it is defective or not functioning as intended. If the oil filter is clogged with contaminants, replace it with a new clean filter. Regularly changing the oil filter is crucial for maintaining proper lubrication. If the oil pressure sensor is faulty and providing inaccurate readings, replace it with a new reliable sensor. If the warning light on the dashboard is not illuminating due to a blown fuse, replace the fuse with a new one. If the oil pressure switch is not functioning correctly, causing issues with the warning light, replace it with a new switch. Locate and repair any short circuits in the wiring connected to the oil pressure warning light. Ensure that the wiring connected to the oil pressure sensor is securely and tightly connected. Loose connection can lead to inaccurate readings or signal disruption.
Let's recap this session on performing troubleshooting and remedy for oil pressure light. We learned that if the oil pressure is too low, the engine won't get enough lubrication, and that can seriously harm or even completely stop your car's engine. Ignoring this warning might lead to expensive repair or, in the worst case, needs to buy a new engine. Pay attention to this warning. Inspect the entire lubrication system including oil passages, pump and other components. Look for sign of blockages, leaks or other malfunction. Ensure that oil is circulating properly throughout the engine. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you. Hello and welcome to this session on performing troubleshooting and remedy for brake and parking brake warning light and performing tracing the wiring circuit of the traffic signal flasher light circuit. Let's start with this topic. On completion of this exercise, the trainee shall be able to determine what is triggering the parking and brake warning lights. Fix the problems with the brake warning lights. Determine why the flasher light is not on.
Tools and equipments required: trainee's toolkit, multimeter, wire cutter, battery, vehicle in running condition, bulb as required, cotton waste as required, wire as required, soap oil as required, brake fluid as required, fuse as required, relay as required. Let's understand the procedures for troubleshooting the brake and parking brake warning lights. First, check the brake fluid level in the master cylinder, and if it is low, then fill it to the required level. Next, check the wire connection in the brake light switch and tighten it. Once the circuit connections are re-examined, then verify the operation of the master cylinder. Then examine the brake light wire connections. If you find any loose connections or open circuits, fix them. If the wire connections are fine, then check the brake and parking light bulbs. If the bulbs are fused or damaged, then replace the bulb. Now check the brake light wire continuity with the help of a multimeter. Next, examine how the mechanical linkage for the parking brake operates. Verify that the brake light cable is earthed properly. If not, then fix it. Check whether the brake light wire is short circuited and fix it. Till now, we have discussed how to fix the brake light if it is not glowing. The other kind of issue will be the brake light stays on always. For this problem, check the brake light switch and wire connection for short circuit and fix it. Another kind of trouble in the brake warning light does not light up and the brake warning light stays on always. If the brake linkage is rusted, then change the brake linkage. If there is any corrosion in brake joints, lubrication will fix the issue. Replace the brake switch if it is defective. If the handbrake lever is not fully released, then check whether it can be repaired or needs replacement. Next, check the brake light connections. If it loose, then tightening the wire connections will fix this issue. Check whether the brake light is fused. If it is fused, then change the fuse. Next, let us check the earthing connection. There may be a poor earthing connection because of corrosion or rust. Cleaning the rust and tightening the wire will solve this issue. Check the brake fluid level in the master cylinder and refill it if it is low. Verify the bulb holder is in working condition. This can be checked with the help of a current tester. If the bulb holder is defective, then replace the bulb holder. Check the brake light's power connection and rectify the issue. The brake pedal linkage may be disconnected. Check the brake pedal linkage and connect it. Finally, check whether the brake light switch is short circuited. Rectify the short circuit in that condition. Let's understand the procedure for checking the flasher unit circuit. First, let's start by checking the battery's voltage. To check the battery's voltage, we should use a high rate discharge tester to check the battery voltage and ensure the correct voltage by referring to the manufacturer's specifications. Next, check the battery specific gravity. We can use a hydrometer to check the specific gravity of the battery. You can check the manufacturer's specifications to check the correct specific gravity. If the specific gravity of the battery is correct, then check the fuse. Inspect the fuse for proper condition. If it is fused, replace them. The next step is checking the bulbs. Ensure that the bulbs are not fused or broken. In case they are fused, then replace them. Once the bulb is examined, then check the status of the flasher circuit connections. You can refer to the vehicle wiring diagram and inspect all the flasher circuit connections are connected. Once the circuit connections are verified, then check the voltage at the flasher unit terminal B. It should have the correct voltage concerning the earth. The voltage can be measured with the help of a multimeter. Next, connect flasher unit terminal B and L together and operate the direction indicator switch. If the flasher light glows, then the flasher unit will be defective. The flasher unit cannot be repaired, so it should be replaced. Before making connection to flasher terminals L, B and P, test the flasher unit by joining cables together and then operate the indicator switch. If the connection is correct, the flasher bulb will glow, but if the connection is wrong, then the ignition auxiliaries fuse will blow without damaging the flasher unit. Now let's understand the procedures for checking the flasher switch. First, we should check the wire connection to the flasher switch terminals. So, we ensure that the wire connected to the flasher switch terminals is properly tightened. After checking the wires are properly tightened, if the flasher switch is defective, then replace the flasher switch. One of the reasons for the flasher bulb not glowing is the bulb may have fused filaments. Also, check the bulb for external damage on the cap or on the contact point. Replace the damaged or fused bulb with a new one. The next step will be tracing the wire from the battery to the fuse. Trace the wiring from the fuse to the flasher unit B terminal. Follow the wiring from the flasher unit L terminal to the two-way switch. Trace the wiring from the flasher unit P terminal to the pilot lamp in the dashboard. Next, follow the wiring from the switch to the left front lamp. Then, trace the wiring from the switch to the right rear lamp. Double check the front and rear circuits. If you find any breakage in the circuit, fix it.
Let us recap this session. Once the circuit connections are re-examined, then verify the operation of the master cylinder. If the handbrake lever is not fully released, then check whether it can be repaired or needs replacement. Verify the bulb holder is in working condition. This can be checked with the help of a current tester. If the bulb holder is defective, then replace the bulb holder. To check the battery's voltage, we should use a high rate discharge tester to check the battery voltage and ensure the correct voltage by referring to the manufacturer's specifications. Ensure that the wire connected to the flasher switch terminal is properly tightened. After checking the wires are properly tightened, if the flasher switch is defective, then replace the flasher switch. Hope you have a clear understanding of this. Do this exercise with the help of your instructor. Thank you.
Hello everyone and welcome to this module on the mechanical motor vehicle. In this video, we will discuss how to dismantle the gearbox, clean the gears using a suitable solvent and check the gearbox and its parts. We will finally assemble the gearbox. By the end of this video, you will be able to dismantle the gearbox, clean the gears using a suitable solvent, check the gearbox and its parts and assemble the gearbox. Let us collect the tools, machinery and materials required to do this. Trainee's toolkit 1, spanner socket pieces with box 1 set, outside micrometer 1, torque wrench 1, feeler gauge 20 blades metric 1, oil can 0.5 or 0.25 liter capacity 1, bearing puller 1, electric pedestal grinder with two 18 cm wheels 1, taps and dies 1, cleaning tray aluminium 45 by 30 cm 1, gearbox 1, kerosene as required, gear oil as required, grease as required, a bunion cloth or waste cloth as required. Dismantling the gearbox. We need to remove the drain and filler plugs that are attached to the gearbox housing and drain the old oil. Next, we remove the shift lever housing pin and then the shift lever from the housing. Remove the shift housing bolts. Remove the gear shift housing assembly along with the gasket and shifting fork from the gearbox housing. Remove the screws and washer of the pinion's shaft bearing retainer with the felt. Remove the retainer and gasket. Remove the lock plate through the slot cut in the rear end of the counter shaft and the reverse idler gear shaft. Drive out the counter shaft by using the brass drift. Allow the counter shaft gear set to drop to the bottom of the gearbox housing. Remove the cotter pin, main shaft and washer. Remove the main shaft rear bearing and rear bearing spacer. Remove the main shaft along with the gear from the case through the rear bearing spacer's opening. Remove the sliding gear, first and reverse gear, from the main shaft. Remove the blocking ring and snap ring. Remove the synchronizer clutch sleeve. While removing the clutch sleeve, take care of the synchronizer plates and remove the synchronizer plates and spring. Remove the clutch hub. Remove the second blocking ring. Remove the second speed gear. Remove the bearing lock snap ring. Drive out the pinion shaft along with the bearing and washer. Remove the pilot needle bearing. Remove the countershaft gear set. Remove the front and rear thrust washers. Remove the roller needle bearings from the countershaft gear set along with the washers and spacer. Remove the reverse idler gear shaft by using a brass drift. Remove the reverse idler gear. Dismantle the gear shift housing assembly by removing the interlocking plunger, the rail caps, poppet balls and springs, shifting fork lock pins, shifting rails and shifting forks. Start by washing the transmission and case thoroughly inside and out and then clean all the components. Inspect the synchronizer rings and cones for wear, crack and overheat. Inspect the synchronizer clutch sleeve and dog teeth for damage. Inspect the hub's splines for damage and free movement on the main shaft. Inspect the synchronizer shifting plates for damage and proper seating. Inspect the blocking rings for wear, crack and overheat. Inspect hub snap ring for proper tension and seating. Inspect the transmission case, bearings and all the gears for crack, wear, damage and overheat. Let us check the gears for free movement on the main shaft and inspect the bushes for wear and damage. Inspect the shaft bores in the transmission case for wear, crack and damage. Inspect the main shaft spline, countershaft bore and main shaft drive for damage. Check the counter gear set, countershaft and reverse idler gear shaft for damage and wear. Inspect the bush, roller bearings for crack, wear and overheat. Assembling the gearbox. Assemble the reverse idler gear and shaft into the case. When fixing, ensure that the chamfered side of the idler gear faces towards the sliding gear. Align the slot on the reverse gear shaft for proper locking. Assembling the countershaft gear set. Insert the spacer into the countershaft gear's hub. Place the washers, one at each end of the spacer and push needle bearings at each end. Again, add washer at both the ends and push the needle bearings. Finally, place one more washer at both the ends and complete the assembly. Place the countershaft gear set in the bottom of the gearbox housing. Ensure that the larger gear faces towards the pinion shaft in the gear housing. Apply grease on the front and rear thrust washers and place them at their respective positions in the gearbox housing. Install two synchronizer springs in the hub with the spring tension opposed. Place the ends of the spring in the slots of the hub. Install the three synchronizer shifting plates in the three slots in the clutch hub with the smooth side of the plate facing outward. Slip the clutch sleeve over the clutch hub. Install the second speed gear on the main shaft. Ensure that its dog teeth face towards the front of the gearbox housing. Place the blocking ring on the second speed gear towards the front of the gearbox housing. Install the clutch hub with the clutch sleeve on the main shaft front end without disturbing the synchronizer plate. Lock the hub with the main shaft by inserting the clutch hub snap ring. Pass the front end of the main shaft in the case through the rear end, bearing opening, and assemble the low and reverse sliding gear on the main shaft. Ensure that the shifting groove of gear faces towards the front of the gearbox housing. Place the bearing spacer on the main shaft rear side. Fix the rear bearing spacer. Assemble the rear end bearing. Place the main shaft washer. Tighten the main shaft castle nut at the recommended torque. Lock the castle nut by the cotter pin. Apply grease and place the pinion shaft pilot bearing in the pinion shaft spigot. Install the bearing washer, bearing, and the bearing snap ring on the pinion shaft. Install the pinion shaft with bearing on the housing and fix the pinion shaft snap ring. Place the oil seal in the bearing retainer. Fix the bearing retainer with a gasket to the case. Lift the counter gear set. Align the counter shaft front thrush washer and rear thrust washers with the bore of the counter shaft gear set. Align the counter gear set bore and gear housings front and rear bores. Insert the counter shaft into the counter gear set. Tap the counter shaft to enter into the front side of the gearbox housing. Ensure the position of the 3 thrust washers. Please check the gear end place as per manufacturer's specifications. Align the counter shaft and idler gear shaft slots. Fix the lock plate. Fix the drain plug. Fill up gear oil to the specific level and fix the filler plug. In this video, we have discussed how to dismantle the gearbox, clean the gears using a suitable solvent, check the gearbox and its parts, and assemble the gearbox. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, let us learn to remove the open type of propeller shaft from the vehicle, remove the universal joints, clean and replace the worn out parts, reassemble and rectify the vehicle and its alignment. By the end of this video, you will be able to remove the propeller shaft from the vehicle, check the propeller shaft for bending by using a V-block and a dial indicator, and assemble the center bearing unit. Let us collect the tools, machinery and materials required to do this. Trainee Tool Kit 1, Double End Spanner Set 1, Ring Spanner Set 1, Benchwise 1, Bearing Puller 1, Circlip Plier 1, Ball Peen Hammer 0.5 kg 1, Dot Punch 1, V-block 1 pair, Dial indicator 1, Vehicle 1, Kerosene as required, Soap oil as required, Grease as required, and a bunion cloth or waistcloth as required. Removing the propeller shaft from the vehicle. Mark the position of the propeller shaft flange eyes. Unlock the propeller shaft's flange nuts and remove them. Remove the rear propeller shaft. Remove the center bearing housing mounting bolt. Remove the front propeller shaft. Mount the special tool on the vise and lock the propeller shaft's flange. Remove the propeller shaft flange nut. Fit the bearing puller to hold the center bearing and tighten the puller's center bolt till the bearing comes out from the propeller shaft. Remove the spacer ring. Dismantle and assemble the center bearing. Place the propeller shaft on the V-blocks on the surface table. Place the dial indicator on the surface table at the center of the propeller shaft and set the dial indicator to 0 position. Rotate the propeller shaft by hand and note down the propeller shaft's bend. If a bend is found more than the specified limit, replace or straighten the shaft. Insert the inner spacer ring in the center bearing bracket. Place the center bearing on the propeller shaft. Tap the center bearing with a drift so that the center bearing sits on the propeller shaft on its seat. Fit the center bearing rubber into the bracket. Fit the center bearing bracket on the propeller shaft. Fit the propeller shaft flange on the propeller shaft. Tighten the lock nut to the specified torque and lock the nut. Fit the center bearing bracket along with the rear propeller shaft to the cross member and tighten the mounting bolts. Connect the propeller shaft and the tail pinion flange and tighten the mounting nut and bolt. Connect the front propeller shaft's flange with the gearbox flange and tighten the mounting nuts and bolts. Dismantle a universal joint. Remove all the 4 circlips from the yoke. Mount the yoke on the vise with a special tool. Tighten the vise jaw till the bearing race moves out 3 to 4 mm. Remove the yoke from the vise. Tap the yoke with a mallet around the bearing race's seat till the bearing race comes out of the yoke. Repeat the above steps to remove all the 4 races from the yoke. Remove the spider from the yoke. Loosen the slip joint locking cap by tapping the propeller shaft yoke with a mallet. Mark the position of the yoke and the propeller shaft to assemble in the same position. Pull out the slip joint from the shaft. Inspecting parts. Check the needle bearings visually for any damage. Replace the bearings if found damaged. Check the free movement of the yoke of the slip joint on the propeller shaft. Check that all the needles are placed in the bearing cup. There will be a gap between the needles if any of them are missing. Assemble a universal joint and refit the propeller shaft to the vehicle. Place the spider on the yoke. Place the bearing with a retainer in the yoke to 3 to 4 mm on the opposite side. Place a flat distance piece on the bearing race and tap it until the bearing race sits in the yoke on its seat. Repeat the above steps for all the bearings. Fix circlips on all the bearings. Coincide the mark of the yoke and shaft and slide the slip joint on the propeller shaft. Tighten the slip joint locking cap. Fix a dirt boot on the front and rear. Refit the propeller shaft to the vehicle. Tighten the mounting bolts of the shaft at the specified torque. The propeller shaft manufacturer provides arrow marks both in the yoke and the shaft. Ensure that they are kept in one line. In this video, we have discussed how to remove the propeller shaft from the vehicle, check the propeller shaft for any bend by using a V-block and a dial indicator, and assemble the center bearing unit. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, let us learn to remove and replace the front wheel drive shaft. By the end of this video, you will be able to identify the constant velocity joint, remove the constant velocity joint, remove the half shaft assembly, clean the constant velocity joint and inspect it, check the condition of the constant velocity joint, bearing and bushes, lubricate the constant velocity joint using the recommended lubricant and refit the constant velocity or CV joint. Let us collect the tools, machinery and material required to do this. Trainees Toolkit 1. Hollow punch set of 7 pieces 6 mm to 15 mm 1 set. Spanners socket set of 28 pieces with box 1 set. Ball peen hammer 0.5 kgs 1. Outside micrometer 1. Torque wrench 1. Bearing puller 1. Crowbar 1. Diesel engine or diesel engine car with manual 1. CV joint as required. Half shaft as required. Cotton waste as required. Soap oil as required. Identify the CV joint. The CV joint connects the drive shaft and wheels. CV or joint removal. Complete boot and CV joint service requires removing the half shaft assembly from the car. Follow the procedures given in the vehicle service manual. Loosen the front wheel lug nuts and the hub nut. Raise the vehicle on a lift supporting the vehicle on suspension. Remove the lug nuts, wheels and hub nut. Removing the half shaft assembly. Remove the nut holding the lower ball joint to the steering knuckle. Separate the lower ball joint from the knuckle. Swing the knuckle assembly and pull out the CV joint from the wheel bearing and hub. Use a slide hammer puller and remove the inner CV joint from the transaxle. Support both ends of the half shaft assembly and remove it from under the vehicle. Place soft jaws on a vise and clamp the half shaft in the soft jaws. Clean the CV joint. Clean the CV joint thoroughly with kerosene and then dry. Inspect the outer CV joint, cut off the boot clamps and remove the boot. Rub the grease from the CV joint between the fingers. If the grease feels gritty, the joint is probably damaged. Wipe away the grease and remove the CV joint from the half shaft. Shafts are retained by a snap ring or circlip. Force up one side of the cage and inner race and remove each ball. Then pivot the cage and inner race so that the cage windows align with the lands of the outer race. Lift out the cage and the inner race. The outer CV joint completely disassembled. Check the condition of the CV joint, bearing and bushes. Inspect the cage for cracks and pitting. This allows excess ball movement and causes a clicking sound during turns. Check the inner and outer races for excess wear in the grooves caused by the balls moving front and back. Shiny areas in the grooves and cage windows are normal. Replace the CV joint only if a part is broken, cracked, severely pitted or damaged. CV joint fault diagnosis. An unusual noise in the drive line of a front-wheel drive vehicle usually indicates a damaged or worn CV joint. Other conditions in the transaxle bearings and tires also create noise. To determine the source of a noise, road test the vehicle. Follow the procedures in the vehicle service manual. A clicking noise while turning indicates a worn or damaged outer CV joint. A clunk when accelerating or deaccelerating indicates a worn or damaged inner CV joint. Shudder or vibration during acceleration is also probably caused by the defective inner joint. Other possible causes include a bad intermediate shaft bearing, outer joint, engine mount, or torque strut. Causes of vibration at highway speeds include out of balance tires, out of round tires or wheels, or an alignment problem. Vibration or growl may also be caused by a bad wheel bearing. To check the wheel bearing, raise the wheel with a jack. Place a safety stand under the lower control arm. Then, spin the wheel by hand while listening at the hub for the bearing noise. CV joint boot inspection. The CV joint boots deteriorate and may crack or tear during normal use. The boots and outer CV joints fail more frequently than the inner boots and joints. This is because the front wheels move through greater angles for steering. Some manufacturers recommend inspecting the boots every time the engine oil is changed. Clean the boots and then check for cracks, tears, and leakage of grease. The clamps should be in place and tight. If the boot is damaged or leaking, replace it. Continued driving will cause the CV joint to fail due to contamination or loss of lubricant. Servicing the half shaft and CV joints. The CV joints and half shaft assembly may be serviced in 3 ways. A boot kit includes a new boot and clamps to install if the CV joint is reusable. A defective CV joint is replaced with a CV joint kit. This includes a new joint, boot, and clamps. If there is damage to the half shaft or both CV joints, a complete half shaft assembly may be installed. Follow the procedures in the vehicle service manual and the kit instruction sheets to install the new parts. Both the boot kit and the CV joint kit include a supply of the special grease used in CV joints. Apply the recommended amount of grease to the joint. Add the remaining grease to the inside of the boot. Then tighten the boot clamps. Installation of the half shaft assembly is basically the reverse of removal. In this video, we have learned to identify the CV joint or the constant velocity joint, remove the CV joint, remove the half shaft assembly, clean the CV joint and inspect it, check the condition of the CV joint bearing and bushes, lubricate the CV joint using the recommended lubricant and refit the CV joint. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, let us learn to overhaul and inspect the rear axle. By the end of this video, you will be able to remove the axle shaft, check the rear axle parts for defects, and reassemble and adjust the hub end play as per the manufacturer's recommendation. Let us collect the tools, machinery and material required to do this. Trainees toolkit 1, puller 1, circlip plier 1, torque wrench 1, hydraulic jack 1, V-block 1 set, dial indicator with base 1 set, vehicle 1, kerosene as required, soap oil as required, bunion cloth as required, differential oil as required, cleaning tray as required and grease as required. Remove the axle shaft. Remove the axle shaft nuts. Then remove the axle shaft. Use puller bolts if threaded holes are provided on the axle shaft. Unlock the lip of the locking plate from the check nut. Remove the check nut and locking plate and nut using special spanners. Place the puller on the hub and tighten the mounting nuts on the hub. Tighten the center bolt. Ensure that the distance piece sits squarely on the axle housing. Tighten the center bolt till the hub comes out of the axle housing along with the brake drum. Rotate the brake adjusting screw to bring the brake shoes closer. Remove the brake shoe return spring by using a spring extractor. Unscrew the brake shoe anchor bolts and remove the brake shoe. Mark the leading and trailing shoes to fit them in the same position later. Unscrew the wheel cylinder mounting bolts and remove the wheel cylinder assembly and backplate. Check the rear axle parts for defects. Check visually the following parts for any wear or overhauling: axle tube threads and bearing seats, wheel studs, axle shaft spleens and flange holes, bearings for scoring overheating, brake linings for wear. If brake linings rivets are protruding above the linings, then the brake lining should be replaced. Brake drum for scoring and polishing. If found scored or polished, it should be turned to the next oversize. Brake hoses for punctures and cracks. Place the axle shaft on the V-blocks on the surface table. The V-blocks should be placed near the spleens and flange. Place the dial indicator at the center of the axle shaft and set the dial indicator to 0. Rotate the axle shaft by hand and note down any deflection of the dial indicator. If the bend in the axle shaft is found more than the specified limit, the axle shaft should be replaced. Reassemble and adjust the hub end play as per the manufacturer's recommendation. Clean all the parts. Fit the back plate on the axle casing. Fit the wheel cylinder assembly on the back plate. Place the oil seal ring on the axle tube. Mount the brake shoes on the back plate and tighten the clamp bolts. Fit the brake shoes retractor springs. Use a spring extractor. Fit the wheel cylinder's slotted pin on the brake shoes. Check the free movement of the brake shoes by rotating the brake shoe adjusting cam. Place the oil seal in the hub and place the drift on the oil seal. Tap the drift so that the oil seal sits squarely on its seat in hub. Smear the wheel bearing with the recommended grease and place the bearing in the hub. If necessary, fit circlips in the hub. Place the hub along with the brake drum on the axle tube. Fit the outer bearing in the hub. Tighten the hub lock nut with a hub nut spanner so that the bearing sits on its seat. Loosen the nut by half a turn and then tighten it till there is no end play. Loosen the nut again by half a turn to obtain a play of 0.02 inches to 0.04 inches approximately. Place the dial indicator with the magnetic base on the brake drum. Ensure that the dial indicator pointer rests on the axle casing. Measure the end play of the hub. If not as per specification, then repeat till the specified end play is achieved. Fit the lock washer and check nut. Tighten the check nut at the specified torque and lock it by the lock washer. Place the axle shaft gasket on the hub. Place the axle shaft in the axle casing and tighten the axle shaft nuts. In this video, we have learnt to remove the axle shaft, check the rear axle parts for defects, and reassemble and adjust the hub end play as per the manufacturer's recommendation. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the mechanical motor vehicle. In today's video, let us learn to overhaul and inspect the differential assembly. By the end of this video, you will be able to dismantle the differential assembly, dismantle the pinion assembly, inspect the parts of the differential assembly, and assemble the differential assembly. Let us collect the tools, machinery, and material required for this. Trainee's Toolkit 1, Bearing Puller 1, Circlip Plier External 1, Bench Vise 1, Torque Wrench 1 set, Feeler Gauge 1 set, Dial Indicator with Stand 1 set, Vehicle 1, Kerosene as required, Soap oil as required, Bunion cloth as required, SAE 120 oil as required, cleaning tray as required, and grease as required. Dismantle the differential assembly. Hold and lock the differential so that the pinion shaft does not rotate. Remove the pinion shaft nut. Use a special tool to lock the pinion. Remove the pinion shaft flange. Drive the end of the pinion shaft with a hammer and brass drift. Take the pinion shaft assembly out. Make marks on both the sides of the caps for identification. Loosen the stopper bolts on both sides. Remove the cap fixing bolts. Take out both the bearing caps. Lift the differential case assembly and hold it on a vise. Remove the bolts fastening the bevel gear to the differential case. Take out the bevel gear. Take out the side pinions, side gears, and thrust washers. Remove the side bearings from the differential case. Use an extractor or a special tool. Ensure that the washer sits squarely on the differential cage and does not touch the inner race of the bearing. Inspection. Inspect the pinion for wear. Inspect the side pinion and side gear for teeth wear and check the bearings for free rotation. Dismantling of the tail pinion assembly. Support the inner race of the inner taper roller bearing of the tail pinion on a special tool and press the tail pinion out of the two taper roller bearings. Remove the outer taper roller bearing assembly. Remove the split spacer rings between the two races. Remove the split washer between the two inner races. Remove the inner taper roller bearing assembly. Ensure that the outer races of the two taper roller bearings are not interchanged. Remove the circlip of the pinion. Inspect the parts of the differential assembly. Check the tail pinion teeth for scoring, burrs, breakage, overheating, etc. Replace the defective tail pinion. Check the bearing seats on the tail pinion for scoring. Check the spleens on the tail pinion and its coupling flange for wear and burrs. Check the threads on the tail pinion. Check the circlip grooves on the tail pinion. Check all bearings for scoring, bitting, burrs, overheating, etc. The crown wheel and tail pinion are replaced as a set. Assemble the pinion in the housing. Fix the inner race of the spigot bearing on the tail pinion. Fit the circlip. Ensure that the chamfered end of the inner race faces the pinion teeth. Press the inner race of the inner taper bearing till it touches the pinion teeth. Use a special tool. Slide the spacer washer on the tail pinion. Place the outer race of the outer taper roller bearing on its tail pinion. Fit the thrust washer on the outer bearing. Place the threaded slotted ring with the new oil seal on the tail pinion. Apply oil on the coupling spleens. Press the coupling flange on the spleens of the tail pinion. Fix a new coupling nut on the tail pinion. Fit the special tool on the coupling flange. Mount the tool on the vise. Tighten the coupling nut at the specified torque. Fit split spacer rings between the two outer races of the taper roller bearings. Fix a special tool on the pinion flange to find out the preload. Move the weight on the bar away from the pinion. Note down the minimum distance between the pinion and the weight at which the pinion starts rotating. Multiply them. This is the preload of the pinion bearings. Compare the preload with the manufacturer's specification if specified. Select a spacer to obtain the specified preload. To increase the preload, use a thicker spacer. Fix the pinion assembly in a differential carrier. Assemble the differential assembly. Fix the side bearings into the differential case by using a special tool, that is, the differential side bearing installer. Assemble the side pinion and the side gear with the thrust washer in the differential cage. Fix a bevel or ring gear on the differential case and tighten the bolts at the recommended torque. Keep the differential case assembly over the carrier case. Place the two bearing caps over the case and align the mark. Fix the dial gauge. Fix the dial indicator needle on the crown wheel on the convex side of the bevel gear tooth. Measure the backlash. To increase the backlash, the crown wheel is to be moved away from the pinion. Loosen the left side adjusting check nut and tighten the pinion right side check nut. Repeat this till the specified backlash is achieved. Tighten the cap bolts at the specified torque. Lock the adjusting nut with the lock plate if provided. Check and set tooth contact between the crown and pinion. Fix the crown wheel study brass bolt if required. Check the differential action by rotating one side wheel. The other side wheel should rotate in the reverse direction. Fix packing on the differential assembly cover. Fit the cover on the differential assembly. Fill the recommended oil to the specified level. In this video, we have discussed how to dismantle the differential assembly, dismantle the pinion assembly, inspect the parts of the differential assembly, and assemble the differential assembly. Hope you have a clear understanding of this session. Thank you all and see you in the next video.
Topic of today's technical session is cracks in buildings, which is a topic of concern for all the civil engineers. The sequence of the presentation will be definition and type of cracks, reasons and preventions for cracks, construction practice and techniques which need to be adopted,